Foundation for the Future is pleased to award the Crystal Prize for 2010 for the one outstanding genetic researcher of our times, Dr. Leroy Hood.
Let's talk a little bit about consciousness. As I've heard it described, consciousness is a biological property of the brain, much like the firing of neurons or the production of neurotransmitters, and biology will someday be able to explain how organic tissue can produce it. Would you agree?
So I would say that consciousness is certainly the hardest biological problem that I know of by far. I would say none of the techniques we have now, that is analytic techniques that we have now, can probably begin to measure the really critical parameters of consciousness. And I think the one hope we have is for imaging techniques that in the future will be able to take precise and detailed pictures of the brain down to the point of seeing how individual molecules in certain cells will change themselves. If we can do that, then I think we can begin to unravel some of and maybe we'll start with issues that might be easier than consciousness, like memory and things like that. Now, we have a little bit of a biochemical handle on memory, but it's at the very, very earliest stages. But I think I just don't see any techniques out there. I mean, because the brain is an incredibly complex system, and because its properties are a consequence of that system, you have to study brain function in the context of the brain. So we have to develop the tools for being able to do that. Mm-hmm. And do I think we will? Absolutely. I have no idea what the time scale for that will be.
With P4, you have described the disease aspects of it. What are the potentials for emotions and behavior?
Well, I think with the kinds of tools that we've developed now, we can really begin to get at complex genetic diseases, such as schizophrenia and many others that have a big component. I mean, the problem with a disease like schizophrenia is exactly the same as a disease like Alzheimer's. Namely, it is an enormously complicated mixture of different entities, and we have to be able to stratify those entities into discrete types that have defined molecular network correlates that we can do. And I think that is going to be possible. And again, I think these iPS cells that I talked about offer us an enormously exciting way to be able to take from any one of you a little bit of blood and get in a test tube whichever of your tissues we need to be able to interrogate to deal with complicated diseases of that tissue.
The reasons for your creating the Institute for Systems Biology, if I'm characterizing it correctly, was based on some disillusionment with the idea of pursuing your interests in the academic disciplines in a university environment. So what would you change if you were in charge and had a free hand to say, you can go about redesigning academia any which way you would like?
So let me explain precisely by, and then I'll answer your question, okay? You know, I think the trouble with any new idea is that it is a mismatch often from the institute in which it rises, because the bureaucracies of those institutes are really formed by the past. So, and they're not set up to be able to deal with the future. Almost no institutions can deal very effectively with the future. I mean, the one example in industry that I've read a lot on, and it's really fascinating, is some of the bigger companies have actually formed what they call skunk works, where they put together a group of people and say, you can work on this new problem, and we're releasing you from all of the profit and loss constraints. And what happens inevitably with those skunk works is when they do succeed, it is impossible to reintegrate them back into the, and almost always they end up going off and being other kinds of companies. So, you know, I think academia does things very, very well. I think what it can't deal with very well is really, truly new kind of innovation. And then I think the best thing to do is to split out, create a new institution. And look, the institution we've created is great for doing what we're doing now, but I have no disillusions about the fact in 20 years we may not be able to deal with the things that are going to come in the future. So it's what I said at the beginning. I think new ideas require new organizational structures, and I think it's really difficult to achieve them in old institutions. Now, is there any chance it could be done in academia? I think there is, if you had leadership that was really enlightened and was really willing to be flexible in ways most deans and most provosts and most presidents are not. But those are really rare traits. So I'd say if you have really new ideas, go get something new started. And now, the downside of getting something new started is really a lot of work, and it costs money, and you have to figure out where you're going to get money and things like that. But that's the way to do it. Start something new.
Will reproduction by sex disappear altogether?
Gosh, I hope not.
Now, the technologies that you are developing have, of course, as you have described, the capacities for disease prevention, prediction, and so on. But the capacities also exist for enhancing attributes of humans. What side of that debate would you fall on as it relates to the capacity to enhance attributes? And do you think that if that were to occur within the time frames that you foresee, will we be creating a hierarchy of humans where some of them have it, some of them don't, and then therefore those that have it will demand more rights, and will the concept of liberal democracy and the equality of humans disappear?
Well, I think that's about an hour answer. So let me say two things. First, we can, by selective breeding, do utterly incredible things. And my favorite example of this are dogs. Dogs have been around for less than 10,000 years now. And the phenotype of the dogs has been driven almost entirely by the breeders, okay? In contrast, a Chihuahua, which can sit in a teacup, with an Irish Wolfhound, which can be 7 feet tall, those are exactly the same species. Those changed from one another in 7,000, 8,000 years. Now, so that's physical appearance. What about mental appearance? Well, think of what they've bred into herding dogs, collies that can herd. I mean, you can breed really fascinating mental traits. So the given is, if we wanted to do selective breeding with humans, we could make enormous, enormous differences. Now, I will say, for all the breeding you do with animals, you introduce a lot of negatives too. Those animals never, ever could survive in the wild, and a lot of them have a lot of problems, as you as pet owners probably know. So we could do these changes in human beings, and would it be a good idea to do it? That obviously is an issue that society would really have to think about and decide. My own guess is that generally most people, and I think myself, would be very much against it for exactly the reasons that you did. You could easily generate haves and have-nots. You might generate a culturally superior race of humans that would be hard on the rest of us. So I would guess there would be enormous approbation at selective breeding. But I will say, evolution is a powerful tool for sculpting whatever the breeder would like to sculpt. And there's no question we could make really dramatic changes. I mean, in some senses, that would be a fascinating way to study how the brain works and things like that. But my guess is few people would accede to that as a reasonable kind of objective.
I'm not sure if you're familiar with Greg Stock, who is...
I am, yeah.
Now, he argues that the market mechanism should be allowed to function no matter what the implications of such technologies are, as opposed to getting businesses and government and other elements involved in this. Do you have a position on that? Will it not actually eventually evolve? Parents wanting to have children that have enhanced attributes, will there be mechanisms by which you can even attempt to stop such a thing?
Well, it isn't that simple, because you're not going to be able to breed what you want in 1 or 2 or 10 or 30 generations, okay? You have to take a very, very long-term view of this, and you'd have to set up a program to make sure it's insured. So I think the market wouldn't stand a chance in pushing those kinds of ideas at all. It's just that the market is looking for something fast and clean, and I would say in genetics there aren't very many fast and clean kinds of things that you could do.
Leon Kass, the chair of the President's Committee on Ethics, the past President's Committee on Ethics, made the following statement, or asked the following question: is it all right to kill a creature made in God's image even before it looks like Him? Is a question.
Is it all right to kill a creature?
He's talking about stem cells and embryonic research and the objections that were raised.
Okay. So I guess, my friend Lee Silver has written a book on this very topic. And one of the critical questions is, when does humanity come into a fertilized egg? And his argument is that takes a certain amount of time, and you have certain options prior to that time about doing things. You can make arguments about, and everyone makes these arguments and pushes them up and down. But I think on the other hand, there are getting to be other routes that are going to be really effective in dealing with these kinds of issues for example, being able to take certain kinds of birth control pills and things like that hit at the root of it even before getting egg and sperm together and things like that. So I think they're talking about how many angels there are on the...
that can dance on the head.
Yeah, and my own feeling is, one of the interesting questions is this recent issue that's come up again about embryonic stem cells, where a federal court judge said, we're going to start restricting that again. So on the one hand, I'm firmly opposed to that, and I think the idea... I guess I don't see much difference between using human embryos that are going to be thrown away for mankind's good than just throwing them away and giving no benefit whatsoever. It's just choosing how you're going to use it. But the other point that's really interesting is with the emergence of iPS cells, there is the possibility you can circumvent any of that kind of argument whatsoever, because here we're taking a differentiated cell and we're converting it to a stem cell, and then we can go to all the different cells you want. There's even a recent report that you can start with one cell and you can move it directly to another differentiated cell by putting certain kinds of factors in it. So my own feeling is we're going to have a lot of ways of dealing with the issues that have choked us on embryonic stem cells and so forth. But in principle, I guess I really question the judgment that it's better to throw things away than to use them to humanity's good.
Fukuyama, the philosopher, has written this book on post-human futures, in which he points out that science and technology from which the modern world springs themselves represent our civilization's key vulnerabilities. Airliners, skyscrapers, and biology labs, all symbols of modernity, were turned into weapons in a stroke of malign ingenuity. What are the potentials for such risks, such dangers, with the kinds of technologies that you are developing? So far, we have discussed all of the positives.
Right. So I think with all technologies, they have the opportunity to do enormous good, and in some cases, they clearly can do bad. There's no question about that. And I think what is really critical is to have not only proper taste and judgment about how to use them, but guidelines and laws that will not let us move in inappropriate direction. So I think it's impossible to argue that you can't use modern biological technologies to be destructive of human beings if you so desired to do it. But I think what I would argue is it's a question of what you wanted. If you wanted to destroy human beings, there are much easier ways than doing it with biology. Okay. And if you wanted to create certain kinds of human beings, it's an awful lot easier than these arguments of we can clone 10,000 Sergeant Yorks in heaven. That's just nonsense, because that says even if you had the right genes, you'd have exactly the same environment that made a Sergeant York, and I've argued that that's going to be virtually impossible. So, you know, a lot of the right-wing philosophers have these very narrow points of view, and they argue them, I think, from a not very broad point of view. But I will say there are technologies that you do have to be concerned about, and that they don't get used in inappropriate ways. And that's why we have laws and Congress to look into these kind of things. They don't always make the right decisions, but it's better than nothing.
I know you touched in your talk on the whole idea of race and genes and so on. If you could elaborate on the following comment: is genetic determinism fact or fiction?
The reason I think you can't answer a question like that is the object of the genetic determinism isn't specified. So what one can clearly say is your genome gives you an envelope of potential that can be enormously modified by your environment. So if you ask me, at the point of birth, is this embryo genetically determined to become a Hitler? Or I'd say utterly not at all. And you know, that's the hope for being able to deal with terrorism, that if we could go to the Mideast and if we could set up schools and jobs and healthcare and things like that, I think you could take away a lot of the disillusionment that exists there. It isn't that they are genetically determined to be terrorists, it's that their environment has molded them into this thing. So rather than worrying about genetic determinism, I'd really worry about the environment and how we can optimize that for education, for all the things that we've talked about. Okay.
Thank you, Dr. Ward. Thank you very much.
Yeah.